So if I consider u of n, let's say this is nothing but unit step signals which always starts from 0, u of n, and for negative values it's always 0. So this is u of n. If I fold this signal, if I find u of minus n means all these samples which are defined for positive values of n will now go on the negative side, but the sample at n equal to 0 will still remain. So 0, minus 1, minus 2, minus 3, and all the samples on positive values of n will now become 0. Please note that these are all the samples which are equal to unit t. So I've got u of minus n, and now I'll have to draw u of minus n minus 1. So u of minus n minus 1 will be nothing but the shifted version of u of minus n. And because both the signs are same, we will shift the signal towards left by 1. So when I shift the signal toward left by 1, the sample at 0 will shift to minus 1. Sample at minus 1 will further shift toward left. So this is how the shifted signal will be generated. This will be at minus 1, minus 2, minus 3, minus 4. And this time samples starting from 0, 1, 2, 3 will become 0. So that's my u of minus n minus 1. So you can see that u of minus n minus 1 is nothing but samples of value. This all values are again equal to 1. But they now start from minus 1 and they go up to minus infinity because it extends towards left. I'll take this minus sign outside. It's a raised to n into z raised to minus n. U of minus n minus 1 is equal to 1 in this whole range. This can further be written as minus summation n equal to minus 1 to minus infinity. I can combine these two terms which will become az inverse raised to n. See, now next what I can do is I can replace n with minus n because my n is taking negative values. If I don't want that, I can replace n with minus n. So if I replace n with minus n which was going from minus 1 to minus infinity will now go from 1 to infinity. And if I'm doing that, this n will also be replaced with minus n. So what will be the reason for this particular step? We have replaced n with minus n. So all the negative values of n is now positive, and here we had n becomes minus n. I don't want to keep this minus sign with the power, so what I'll do is I'll send it inside. So we get minus summation n equal to 1 to infinity. If I send it inside, I'll get a inverse z raised to n because this minus z was already having minus 1 of power, so that becomes plus, and that minus sign goes with the power of a, so it becomes a inverse z. And this is again the geometric progression. Please note that this time n starts from 1, so the summation will be the first term which will be a inverse z upon 1 minus the common ratio which will also be a inverse z. Now this can further be written as, if I just simplify it a little bit, it becomes z upon z, and there is this minus sign also here. So if I simplify this whole thing, it becomes z upon z minus a. So now if you observe, this z transform is exactly same as the previous z transform. Then the question is, what is the difference between them? So let's figure out the difference between them. I can apply this formula of the geometric progression only if mod a inverse z is less than 1. So that's a condition now, and if you solve this condition, it gives you mod z less than, this a inverse goes on the other side, becomes mod a, and this gives me what we have called as ROC. So you can see both the signals have the same Z transform, but they have different ROC, and that's what makes them different. So if I quickly draw the new ROC of this particular signal, I'll take the same circle of radius mod A again because this is still mod A. So I'll just mention it outside. The radius is equal to mod A. But this time if you see carefully, the ROC is mod Z less than mod A. So it's the region which is inside this circle. So this is my ROC. In the previous case, ROC was exterior to the circle. In this case, ROC is interior to the circle. So that's the difference. Otherwise, the expression of the Z transform remains same.